Good evening, welcome to You Ask, We Answer.
So in the program of today, we're going to explain you some tips of your daily life. Let's go with our first call. Good evening, miss.
Hello.
Hello, what's your name? Tell us what are you worried about?
Hi, my name is Karen. Well, my little problem is that all the washing soaps I have always used, they all finish damaging my skin. How can I manage it? Is there any way I can prove if they are not damaging?
Okay, Karen's question is so interesting. So in this point, we have to formulate the question for the program of today, which is why some soaps could damage our skin. So let's move to the laboratory.
Good evening, everyone. In our first question and experiment today, we will show you how to prove if any substance can be harmful to our body. So, why does a substance damage us? If we are right, we think that your soap is not adequate to your skin because your skin has an acid pH, while soap normally has a base pH.
Well, to understand that, we first need to learn some concepts. A pH is the amount of hydrogen in a solution. The pH scale goes from 0 to 14, so a pH of 7 is neutral, meaning that the amount of hydrogen and hydroxide ions are equal in a solution.
So, in this scale, we find three types of materials. Acid substances that have a pH from 0 to 6 and base substance from 8 to 14. Because remember, 7 is the middle, so it is neutral. This is the third type of substances. So, we can see that acid and bases are opposite substances.
For that reason, our skin, as all the other materials, has a pH value that differs on every person. Generally, it is from pH 5.5 to 6 in the adulthoods. So for that reason, if we apply a substance with a higher or lower pH, it will damage our skin. How can we know if a substance is adequate for our skin, or in Karen's case, if soap is not harmful for our skin?
Very easy. We just need the soap we want to analyze, in this case, this one, red cabbage, water, and a mortar.
Red cabbage contains a water-soluble pigment called anthocyanin that changes color. At a macro level, we can see that the red cabbage juice changes its color when it is mixed with an acid or a base. Do you understand it?
Yes, I think so. So, if a liquid is base, it will change to blue and green, and it will change to red if it is an acid. How can we obtain our pigment? By smashing leaves of the red cabbage with water to obtain a purple liquid like this one, because we have prepared it before.
Vale.
The pigment turns red in acid environments with a pH less than 7, as we have said, and the pigment turns blue-green in basic environments with a pH greater than 7. So, if we mix the liquid with our pigment, this is the soap and this is our pigment, with other substances it will change its color depending on if it is a base or an acid. So, let's try with our soap.
Necesitamos más.
Tira-li més, tira-li tot. So, answering to Karen's questions about why those soap damage us, as you can see, it turns into a blue tone that shows us that it is a base substance, fact that proves that it can damage our skin. If it didn't change, it wouldn't damage and be harmful for our skin.
Because it will be neutral.
Hello,
Hi,
scientists!
Hi!
So, that's why the soap harmed Karen's skin. So, if we want to find a proper soap, we have to look for a soap with neutral or a little bit acid pH, since Our skin is a little bit acid. You can find them in pharmacies or supermarkets.
Yeah. So we have done the experiment with the soap. We can prove other quotidian substances such as Modena vinegar, lemon juice, and ammoniac.
Yeah, you can use our liquid we have prepared before.
Wow, so we have seen that the lemon juice and the Modena vinegar are acids since they have turned it into red colors. This is lighter and this is darkest. And on the other hand, the ammoniac has changed it into a green color because, as we have seen, it is a base. So with this incredible experiment, we have improved our knowledge in this file and facts about our daily life.
So now let's listen to the next question. Hi, Miss.
Hi, I'm Nuria. I wanted to know if